Welcome to section 8.4. We're dealing with the determinant of a square matrix, and I want to go back through two of the three methods that we did in our notes yesterday for 8.3 and finding an inverse. I want to first start with a doubly augmented matrix. Remember, this was on the quiz, but if you take a look, we take our matrix 1, 2, 3, 7, and we augment it with the identity, which is a 2 by 2 identity, and we use our Gauss-Jordan elimination to do this. So we're going to multiply -3 times row 1 and add it to row 2. So that means row 1 will stay the same and row 2 will change. Well, -3 plus 3 is 0. -6 plus 7 is 1. -3 plus 0 is -3. And 0 plus 1 is 1. Okay, so we've eliminated the x portion of it. Let's eliminate this 2. So we take -2 times row 2 and add it to row 1. That means row 2 in this case now stays the same. And let's see what we end up getting. 0 plus 1 is 1. -2 plus 2 is 0. We've got the identity here, which is nice. 6 plus 1 makes 7. And -2 plus 0 makes -2. This is now my inverse. So my inverse is the matrix 7, -2, -3, 1. Okay, now that was one way that we did it in section 8.3 was the doubly augmented. We also talked about the shortcut that we used in algebra 2, and I want to go through that one more time as well. And in order to find the inverse using the shortcut, we said take the 1 over the determinant, which is AD minus BC. I switch the A and the D, and I make the B and the C opposite. So according to this for our matrix, I take 1 times 7, which is 7, minus 2 times 3, which is 6. So I get 1 over 1. And now I switch my matrices. So A and D switch, so 7 and 1. B and C become the opposite. And if I multiply everything by 1, you see that I get the same thing. So my inverse is 7, -2, -3, 1, which is exactly what we found using the augmented as well. Now, just be careful because you know both on quizzes and tests, we do give you the directions as to which method we would like you to do. And so be careful of that. The determinant of a matrix, which we say DETA, and DET is one of the things you'll find in your calculator under your matrix operations, but we write it as the absolute value of A, and that's just saying find the determinant, and we said the determinant was AD minus BC. This determinant only works for a 2 by 2 matrix, so just be aware of that, okay? In words, the way we say it is it's the difference means subtraction, of the product means you multiply, of the diagonals. Okay, so that means I subtract whatever I get when I multiply each diagonal. And that's this idea of AD minus BC. Okay, and so that's back again to 8.3. I just wanted to look at it one more time because I don't think we hit the shortcut very much in that. Now, the question is, what happens though when I don't have a 2 by 2 matrix? Because I can easily find the determinant of a 2 by 2 by doing AD minus BC. But if I have a 3 by 3 or a 4 by 4 or a 5 by 5, something like that, I can't find the determinant using this shortcut. So we're going to look at a problem where we have to find the determinant of something bigger. Okay, now, in order to do this, we have to look for things that are called minors. And minors are obtained by deleting a row and a column. And so here's how it works. Because there are 9 elements, I'm going to go through how to find all 9 minors. And I'm going to label them like we labeled each element. I'm going to find the minor for row 1, column 1. I'm going to find the minor for row 1, column 2, minor for row 1, column 3. And I'm just going to do this real quick and write these all down. Minor for 2, 3, minor for 3, 1, 3, 2, minor for 3, 3. Okay, and so this is our goal, is we're going to be finding these minors. Now, in order to find the minor, what we're going to do is basically cross off a row and a column. So the way it works is, as I'm finding the minor of row 1, column 1, I go to my matrix, and it's like I were to cross out, and I'm just going to do this real quick, cross off the row, cross off the column. Now, don't actually do this, or if you do this, use a pencil so you can erase as you go through. If I cross these off, I'm left with a 2 by 2 matrix like this. And so what I'm going to do now is do AD minus BC. So 5 times 9, I'm going to write this kind of right below, 5 times 9 minus 6 times 8. Well, this is 45 minus 48, so negative 3. Okay, and you're going to kind of go through. Now, I'm going to show you this in the long version. We're going to show you how to simplify it in a minute. But what I'm going to do now is I'm going to erase this, and I'm going to do it again. So now that I'm going to row 1, column 2, I cross off row 1, I cross off column 2, and I'm left with this 2 by 2 matrix. So I do the diagonals again. So I do 4 times 9 minus 6 times 7. All right, well, 4 times 9 is 36, minus 42 is negative 6. Okay, I'm going to erase again. And I cross off now row 1, column 3. I'm left with this 2 by 2 matrix. So 4 times 8 minus 5 times 7. 4 times 8 is 32, minus 35, you get negative 3. Okay, so now I go to row 2, and I'm going to do the same thing. I now am looking at 2, 1, so I cross off row 2, column 1, and I get 2 times 9 minus 3 times 8. Well, 2 times 9 minus 3 times 8 is negative 6. Okay, let me erase and go through again. So now I'm going to cross off row 2, and I get 1 times 9 minus 3 times 7, and you end up getting negative 12. Okay, and do it again. Cross off this one. And now I'm going to cross off column 3. So 1 times 8 minus 2 times 7, you end up getting negative 6. All right, so I do my last row, and I'm looking at row 3, column 1. So I do 2 times 6 minus 3 times 5. I end up getting negative 3. And I'm going to keep going. If you kind of see this idea, I'm just going to give you the last two. You get negative 6 and negative 3. And these are what we call minors. And minors are basically just found by eliminating, by eliminating the row and the column of what you're working on. Okay? Now, once you find your minors, you have to find, secondly, what we call a cofactor, because you need the cofactor in order to find a determinant. A minor just kind of gets us there. When you look at a 3 by 3 matrix, they give you what they call a cofactor matrix. And what it does is it starts positive, negative, positive. And row 2, it starts negative, positive, negative. Row 3, positive, negative, positive. And it always starts positive in the first column, and then you'll see it alternates in every direction. Now, what this does, though, is it's going to help us then determine what we call our cofactors. So if I look at the cofactor of 1, 1, what it means when it says positive, positive means stay the same. Negative means make it the opposite. Okay, so if I keep the minor for 1, 1 the same, I get negative 3 as the cofactor. The cofactor for 1, 2, because the second column is negative, means change this to the opposite, you get a 6. The cofactor for 1, 3, because it's positive in that position, you leave it the same, so it's negative 3. The cofactor for 2, 1 is negative, so you make it the opposite, so positive 6. The cofactor for 2, 2 is positive, so you leave the negative 12 the same. And the cofactor for 2, 3 is negative, so you make negative 6 a positive 6. Last one, cofactor for 3, 1 is positive, so you leave the negative 3. Cofactor for 3, 2 is negative, so you make the negative 6 a positive 6. And cofactor for 3, 3 is positive, so you leave it at a negative 3. okay? And so we've now just found what we call our cofactors that will help us find the determinant. Now what I'm going to do is switch colors so you can kind of see how this works. If I'm going to take my matrix, I'm going to figure out one row or one column to actually use to find the determinant. So I've done all of the work, now I can actually find it. And what I'm going to do is pick the row 1, 2, 3 because those are the smallest numbers. And what I do is I take the values in that row, okay, and I multiply them each by their cofactor position. So 1 will get multiplied by cofactor 1, 1, which is -3, plus 2 is going to get multiplied by 6, so 2 times 6, plus 3 gets multiplied by the third cofactor, which is -3. And this is going to tell me my determinant. So as I looked, I have -3 plus 12 plus -9, and that ends up being 0. Okay, so the determinant of matrix A is 0. And the biggest thing, again, I'm showing you, this is kind of the big version of it, and we're going to shorten this kind of as we go through, but here's the idea. You need these cofactors in order to be able to find the determinant, and you need the minors in order to know what the cofactors are. So it's kind of a 3-step process as you go through. Now, going back to Algebra 2, if the determinant is 0, that means that no inverse is found for matrix A. So matrix A in this case will not have an inverse. And if you tried to actually go in your calculator and try to find an inverse, you would find that you get some sort of error, does not exist, whatever. And so this is kind of the idea. You can check your determinant in your calculator, do the determinant of A, once you plug it in, you should get 0 out also. This definitely, though, is a no calculator idea, so if you're going to use your calculator, only do so to check your work, okay? So we're going to try another one, and I'm going to see if I can simplify this a little bit for you. And the reason I simplify this a bit is because I don't want to have to find all 9 minors and cofactors if I'm only going to use 3 of them. And so what I'm going to do is find a row or a column that looks the easiest. Okay, now I am going to pick this second row, one because it has a 0, and secondly because all the other numbers are positive. And if I'm doing that, then I only need the minors for 2, 1, row 2, column 1, the minors for row 2, column 2, and the minor for row 2, column 3. And then I don't have to spend the time looking at everything else. And so if I do that, if I find the minor for row 2, column 1, I cross off row 2 and I cross off column 1. And I'm left with the values 1, 2, 4, 2. So I do the determinant of that. 1 times 2 minus 2 times 4. And I end up getting 2 minus 8 is -6. Okay? Now let me erase this a second because I'm going to change now which row I cross off. Now I'm going to cross off row 2 to find the minor for 2, 2. And I have -1 times 2. Let's try this again. Minus 2 times 3. So -2 minus 6 is -8. And I'm going to do this one last time. I'm going to cross off row 3, or I'm sorry, column 3. And I have -1 times 4 minus 1 times 3. So -4 and -3 is -7. Okay? So you're looking at now, I only had to find 3 minors because I've picked that row to use. And that's what kind of our shortcut is decide a row or a column to use first. Because I have those, now I can talk about the cofactors, and we need to decide again if they're going to stay the same or if it's going to switch. And so what I do is I always actually draw out this cofactor matrix and say positive, negative, positive, negative, positive, negative, positive, negative, positive. And I've picked this row to work with. What that means is my first cofactor will change, so a +6. My second cofactor stays the same, so -8. My third cofactor changes, so— and now in order to find the determinant, what I'm going to do is take the value in the matrix times its cofactor, so 6, plus the value in the matrix was 2 times its cofactor is -8, plus the value in the matrix was 3 times its cofactor was 7. All right, so 0 plus -16 plus 21, I get a value of 5, which means the determinant of matrix A then is 5. And this is what you would want to do, again, in order to figure out the determinant of a 3 by 3. Same thing with a 4 by 4, and we're going to do that together as well. But again, the shortcut is to figure out which row or which column you want first. So last one, let's try one a little bit bigger. Okay. And so here's what I'm going to do. I'm going to look at this and pick a row or a column, and I can tell you which one I'm going to pick up off the bat. This one right here. Because if you look, I have 3 zeros, which means really I only need to find one minor and one cofactor. So here's what I'm going to do. I'm going to find the minor for 1, 3. And if you look, if I label it, this is 1, 3, 2, 3, 3, 3, and 4, 3, if I look at these. And so really, in order to find the determinant of this matrix, I would take 3 times the cofactor of 1, 3, plus 0 times the cofactor of 2, 3, plus 0 times the cofactor of 3, 3, plus 0 times the cofactor of 4, 3. Now, do we care about any of these cofactors? Absolutely not, because if I'm going to multiply by 0 anyways, it doesn't matter. So when I talk about this cofactor of 1, 3, what I'm going to do is I'm going to cross off, and let me change color so I can show you kind of what I'm doing. We're going to cross off row 1 and column 3. So to find the minor for 1, 3, here's what goes on. The problem is, you'll notice now I'm left with -1, 1, 2, 0, 2, 3, 3, 4, 2. And if I want to find the determinant of this, I got to pick again a row or a column to do the minors and the cofactors. Now, here's what's nice for us. This is the matrix above. And so we've already done all of the work. And we picked this second row. And in order to find the determinant of this matrix, we said you take 0 times 6 plus 2 times -8 plus 3 times 7. And we said the determinant of this matrix was 5. And so if the minor then, the minor of this matrix, the minor of the bigger matrix is the same thing as the determinant of this smaller matrix, then I know the minor is 5. And again, we just did all of the work up there, but anything that's bigger, again, you'll have to break down and do more minors and cofactors for. The problem is the cofactor going to be the same, or am I going to change this? And I'm going to go back to that idea of the cofactor matrix. I always start positive, but now I have 4 terms, so I'll go all the way for 4 terms. And then the second row starts negative, positive, negative, positive. Third row starts positive, negative, positive, negative. Fourth row, negative, positive, negative, positive. And since I picked this row right here, or this column, and I'm looking at the position here for the 3 to do my cofactor, what it says is it stays the same. So 5 is going to be my cofactor. So in order to find the determinant, we take 3 times 5, which then ends up being 15. And this is a pretty well drawn out example, and I think we do give you one in your homework that's a 4 by 4 to try and help you practice it. But again, so if you want to find the determinant of a 4 by 4, you first have to find the determinant of whatever 3 by 3 is left. And so this is kind of the idea. And again, this one gets a little bit more confusing. But the idea is, if you understand about, find a row or a column, and then find the minors and the cofactors for that row, and multiply it by the numbers in your matrix. And so that's the end of section 8.4. Again, I'm going to give you a warm-up when you come in so that you can practice it, look at it. But again, know the idea of what a minor is and what a cofactor is.